Hello and welcome to Vork. I'm Brian Watrous. This is the third in a 10-part video series in which we're exploring how to build a vCenter Orchestrator environment on top of VMware Fusion. In the previous video, we studied how to download the various software components that we need to build this environment, and in this video, we're going to be taking a look at how to build a DNS server which could be used in conjunction with this environment. Why does our VCO lab environment need a DNS server? Well, we need something like a DNS server so that we can do forward and reverse name lookups. We need to be able to do short name lookups and FQDN lookups. In other words, the various machines in our environment, whether they're the host or the vCenter server or the VCO server, they got to be able to look each other up, and DNS provides an easy way to do that. Now we could opt instead, and this is actually the way I started doing this project, we could instead use the traditional /etc/host file. That turned out to be pretty painful in my experience. I won't go into all the reasons, but some of them are, if we're going to set up /etc/host, that means we're going to have entries in that file for each ESXi host, where we would need an entry for the vCenter server, we need an entry for the VCO server, and that's not that many servers to be adding into a /etc/host file, but I would have to create that /etc/host file on each host, so that's 2 copies of /etc/host, and in the VCO server, and I'd have to do it in the Mac OS 10 side of the world, and so it's just a lot of work. And additionally, the Windows 7 VM would also need to do DNS lookups, name lookups. So if I was using etc host, I would have to go into Windows, and as you can see in the bottom of the slide here, even the path name to where the host file resides is completely different on a Windows 7 VM. So for a whole slew of reasons, using /etc/host can be done, but for a whole slew of reasons, it's just a painful way to go. So I opted to do a DNS server. So if I'm going to do a DNS server, then the question that naturally arises is, which DNS server should I use? Because there's actually a number of DNS servers I could have chosen. For instance, I could have used my corporate DNS server, but one of my goals for this project was to have a VCO lab environment that I could use on the airplane. And on the airplane, I can't get to the corporate DNS server. So that option was out. Another option was to spin up an additional virtual machine running Linux in my environment and run a DHCP, a DNS server in there, but that just seemed like more complexity than was necessary. I didn't want to chew up more CPU and chew up more memory, so I tossed that idea out. I could have set up a DNS server in my Windows 7 VM, but besides the fact that I didn't want to research how to do that under Windows, the simple fact remained that I want to be able to power off the Windows 7 VM once my environment's all up and running. So that option was out too. So what I opted to do, the solution that worked for me was to take advantage of the DHCP server that resides in Mac OS 10. Again, I'm running Mac OS 10, 10.0.8, and it already has all the software that I need to set up a DNS server. I do have to set up some configuration files, but the software is all there. So that's the approach I chose. Now, you don't have to do things that way. If you want to set up a DNS server a different way, if you want to set it up in a Linux VM, or you want to use your corporate DNS server, or if you want to use /etc/host, you can do the name resolution however you want. But if you're like me and you want to take advantage of that MacBook Pro that you got, you can follow the directions I'm going to outline in the following slides. So to configure DNS, by the way, I'm going to use the terms DNS and bind interchangeably here. You smarty pants out there who know the relationship between those two know that I'm using the terminology a little bit loosely here. I'll just call it DNS. And same thing for named. They're kind of all one and the same thing. Anyways, to set up a DNS server on my MacBook Pro, there were essentially 6 steps I had to go through. 1, I had to generate an RNDC key. I'll tell you what that is in a moment. 2, I had to find out what the network address was that Fusion was assigning to my virtual machines. 3, I had to configure the /etc/named.conf file. That's the main configuration file for DNS And then in steps 4 and 5, I need to configure the files that contain the information for how to perform forward lookups and reverse lookups. And then last but not least, I needed to go into the terminal window of my MacBook Pro and run named itself. Now, in the following slides, I'm going to show you many of these steps here. If you want to see all the steps, including that last step of how you actually start named, be sure to watch the demonstration that's included in this video. But let's take a look at the first step. The first step is you have to generate an RNDC key. Now, I first started doing DNS many years ago, like 20 plus years ago. And it's been quite a while since I've actually touched a DNS server or touched bind. So I was a little bit surprised to find this thing called RNDC and the RNDC key. But the idea behind the RNDC key is pretty straightforward. The key contains a shared secret that's used to encrypt your DNS lookup sessions. In order to generate the RNDC key, the software that you need to do this is already there. To run that software, you first of all have to start up a terminal window in your MacBook Pro. You'll be logged in as an ordinary user. For instance, I'm logged in by default as my Brian W. account. Now, that account doesn't have the power to run various utilities that we need to run. So by typing sudo space -s, that's sudo -s, at the non-root prompt, that's what the $sign is, don't type the $sign. By typing sudo-s, that says I want to change my identity to become the super user, the root account on this here MacBook Pro. So I type the command, I'm prompted to type the root password, I type the root password, and then the shell prompt that I get back is a £sign prompt. Again, that's just a shell prompt, don't type the £sign. The £sign is just a prompt that's telling you you're now logged in as root. So at root's £sign shell prompt, to generate the RNDC key, I run rndc-confgen space -a because I want to add a key, -c, which says, okay, here's the name of the file that we're going to store this key in, and so it's a configuration file. And the name of that actual configuration file by default is /etc/rndc.key. To keep things simple, I use the default file name for the RNDC key file. Now the following lines down here are not actually part of the command, but rather I'm actually showing you the contents of my rndc.key file. So in there's just 4 lines. There's a line that begins key space rndc key, which says the following stuff is an RNDC key. The second line says the algorithm that we're using, but it's the third line that's the critical line here. That's the shared secret that's going to be used to encrypt the sessions. Now, truth be told, I just said that this was my rndc.key file. It's actually not. I changed the secret. The secret will look something like this, but do as I did. Don't show anyone your secret key, because if you do so, they can defeat your encryption. The files that you're going to see in the slides that follow can all be downloaded from the URL that you see on the screen here. And just before I show you those actual files, I want to remind you that one of the steps that we need to perform after generating the RNDC key was we need to find out the network address that Fusion is assigning to virtual machines that get plugged into the Share with My Mac network. And I'll show you in the demo how to actually get that information. On my system, the network address used in that network is 172.16.245. So you'll see that number coming up here in a few moments. So the first file that you're looking at here is a file called /etc/named.conf, and the portion that you see here is just a snippet of that file. There's more to the file than just this, but what you see on here is largely exactly what the default named.conf file says. The default named.conf file on my MacBook Pro has a line that says options. Underneath that, it has a line that says directory, followed by the name of a directory. That line's really important. That line says all the files that I'm about to show you reside in that directory. So in the continuing portions of this named.conf file, you're not going to see the name of the directory where the files reside. All the files will show is the name of the file, and you have to remember that /var/named is where they actually reside. The following lines are just a bunch of comments. So in DNS, in the named.conf file, you can put comments in. So go read about DNS, and you can learn about those comments. For our purposes, the key thing to know about these comments is that DNS just ignores them. But down here, this is what I had to add to my named.conf file. Actually, strictly speaking, I didn't have to add these lines. If I don't add these lines, presumably named DNS is going to listen on all the IP addresses that my MacBook Pro is listening on. But I wanted to be explicit about exactly which IP addresses I wanted the DNS server listening on. So I specified I want it listening on 127.0.0.1, which you'll recognize as the local host IP address. So that enables me when I'm outside of Fusion and I'm just on my MacBook Pro. That means that the MacBook Pro itself can use this DNS server that we're looking up to perform name lookups. The second line, though, is perhaps even more crucial. This is the IP address that the DNS server is going to be listening on. So my virtual machines that I'm running in Fusion, if they want to do DNS lookups, they got to go to 172.16.245.1. Continue with the named.conf file. Everything that you see on this screen here is just taken straight out of the default named.conf file. There's actually 3 sections here, or zones. The first zone gives us information about where DNS needs to go in the situation where somebody asks DNS to look up the IP address for a name that this DNS server doesn't know about. So for instance, whereas my DNS server is going to know about a domain such as example.com or whatever your domain is, my DNS server doesn't know anything about other domains like vmware.com. So the first zone here is giving DNS instructions about where to go to find out answers for domains this DNS server doesn't know about. It's instructed to go to the named.ca file. Again, remember that's in /var/named. So the DNS server needs to go to named.ca, and in there it will find what are known as root nameservers. Take a look in that file sometime, and it's pretty well self-documenting, but those root name servers are what allows the worldwide DNS services to help get you directed to a DNS server that can answer the lookup that your DNS server couldn't look up. The next zone, actually the next 2 zones, have to do with what you might call localhost. So this second zone here, the one that says zone localhost in blah blah blah, is essentially saying that if anybody attempts to do a forward lookup on the name localhost, then the file localhost.zone is where we'll find out the corresponding IP address, which you and I know is 127.0.0.1. If you look in that file, you'll see that's exactly what that file is saying. In the third zone that we see here, you see a zone that's a little bit weird looking. It ends in in-adder.arpa. Now I'm not going to go into the whole history of why this is, but reverse lookup zones in your named.conf file are all going to end in .in-adder.arpa. The portion before the in-adder.arpa is the network address that this zone defines. And notice that the network address is in reverse order. So instead of 127.0.0, it's 0.0.127. Again, if this is your first time looking at a named.conf file, that line will look totally bizarre, and you just got to live with it, because that's the way things work in named.conf. There's actually a good reason why it works that way, but that's just the way it works. So if somebody's attempting to do a reverse lookup on 127.0.0.1 or 127.0.0.2 or anything in the 127.0.0 network address, then the named.local file is where this DNS server is going to find the name that corresponds to the IP address that you're looking up. Again, everything on this slide here is just taken straight out of the default named.conf file. No changes necessary to these sections, to these zones. But what I did do was add 2 new zones into named.conf. And these two zones are for forward lookups, that's the first zone, and reverse lookups. And if you look at these entries here, they largely follow the format of the last 2 zones on the previous slide. So in this first zone, the forward lookup zone, the first line is specifying that if anybody's trying to look up a machine in the domain vvork.info, that's my domain. Obviously, you would want to change that domain name to something else. If your domain is example.com, you would change vvork.info to example.com. But in my case, if somebody attempts to do a lookup of a machine such as www.vvork.info or esxi01.vvork.info or vco.vvork.info, then the place that this DNS server is going to go to find the corresponding IP address is the file called named.vvork.info. And then down below, we have our reverse lookup zone definition. Again, we see the the network address that this zone is authoritative over. So 172.16.245. Remember, you have to switch the order to 45.16.172. .in-adder.arpa, the usual thing. Now, in the case of the name of the file, I chose for the name of the file to go ahead and put the network address in the more familiar forward fashion. So named.172.16.245. If you wanted to, you could have called the file named.245.16.172. You just need to make certain if that's what the name of the file is in here, in the named.conf file, then the actual file name needs to match. So in the next couple of slides, what we're going to do is take a look at those two zone files that we just declared in named.conf. So we're leaving /etc/named.conf, and in this screen, what we're looking at is the file called named.vvork.info. And to create this file, I actually just took the forward lookup file for localhost. Again, that was the file named.local.ca or named.local. I just copied that file, and essentially I just added to it the 4 lines down on the bottom. Before I talk about those, there is one change I made up top. In the world of DNS, when you're configuring the various files associated with DNS, there's something called the serial number. Every time you make a change to one of these files, you're supposed to increment the serial number, which is a fancy way of saying just bump it up by 1. You can use any serial numbers that you want, but every time you make a change, you need to increase that number. In the case of the example I'm showing you here, I'm using a pretty common serial numbering convention here, where let's see, the first 4 digits are the year. This is the year 2014. 06 is the month, that's June. 26, that's the day of the month. And then the last 2 digits allow me to make multiple changes on any day of the week. So my first entry, as you see here, ends in 00. If I make a change again today, I'll make the next file 2014062601 and so forth. So use whatever numbering scheme you want for the serial number. Just make certain you increment it by at least 1 every time you make a change to these DNS files. But the real action in this file, the forward lookup file, is the last 4 entries where we have what are known as address records. That's what the letter A stands for. So what these 4 address records are specifying is that if somebody's attempting to do a lookup on esxi01.vvork.info, and it doesn't say vvork.info here because we already know that this is the forward lookup file for vvork.info. So all these names are going to be short here. But if somebody's looking up esxi01.vvork.info or esxi02 or vcva or vco.vvork.info, then the IP address that the DNS server is going to return for each of those respectively is 172.16.245.101 for esxi01. For esxi02, it'll return .102. For vCVA, it's going to return 103. And for vco.vvork.info, it would return 172.16.245.104. Now, one of the things that you may be wondering here is how I came up with those IP addresses. Again, in the demo, I'll show you how I came up with the network range, the 172.16.245. If you're using the share with my network in Fusion, from what I can tell, the 172.16.245 is what Fusion always uses for the share with my Mac network. If anyone sees differently out there in the world, feel free to leave me a comment here to let me know if that information is incorrect. But even if you know the network address, you still have to make certain that the IP address that you change is not conflicting with any dynamically assigned IP addresses. DNS DHCP assigned IP addresses that are given out by Fusion. Now, if you continue all the way through this entire video, at the tail end I have a little bonus section where I talk about the DHCP server that Fusion has built into it and how you can find out what range of IP addresses it is giving out. Because we need to make certain that the statically assigned IP addresses that we're picking here don't collide with the DHCP assigned addresses from the DHCP server and the Fusion hypervisor platform. Alright, so that's the forward lookup file. The reverse lookup file, which again you'll recall I call mine named.172.16.245, is just the opposite of the forward lookup file. So whereas the forward lookup file has A records that allow us to map from a name of a machine to its IP address, the reverse lookup file does just the opposite. Using pointer records instead of A records, it uses pointer records to indicate if somebody's doing a lookup for instance, 172.16.245.101, then this DNS server is supposed to respond with esxi01.vvork.info. So that's what's going on in this particular file called the reverse lookup file. And those are the, let's see, 1, 2, 3, the named.conf, the forward lookup file, and the reverse lookup files are the only files that you need to set up. Oh, almost forgot one, the RNDC key file. There's only these 4 files that you need to set up to get your DNS server configured. What you do need to do, though, however, is to, once you've made all those modifications to those files, you need to start the DNS server, which I'll show you how to do in the demo right now. Earlier in this video, I showed you the 6 steps that are required to set up your DNS server on your MacBook Pro. In this demonstration, I'll actually show you the steps in action. So the first step was to create an RNDC key. To do so, we'll go to the Applications folder, and here we'll go to Utilities. We're going to start up a terminal window. And as you can see in this terminal window, by default, I'm logged in as an account called Brian W., which does not have sufficient powers to do what we're attempting to do. I need to switch to the account called root, which is the super user account on your MacBook Pro. Now to do so, I'll run a command called sudo space -s, and normally when you run that command, it would normally ask you to authenticate. It would ask you for a password, but because I've used sudo recently, it's not going to ask me. So I'm automatically taken into my shell as root, which is why we have a £. So normally you'd be prompted for a password, and the password it's asking for is the root password, which is also the password, the system administrator password that you set when you install your MacBook Pro. So I'm already logged in as root, and to create the RNDC key, we'll run rndc-confgen-a-c, and I'm going to use the default file name, which is rndc.key. And as you can see, it's created that file. If you'd like to see that file, you can simply type more/etc/rndc.key. And in that file, you can see that currently, I'm going to change this afterwards because, again, you shouldn't be showing someone your secret key, but my secret key is CG6YH blah, 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 blah. So I now have my key. Now, the next step that we need to perform is to find out what the network address is for VMware Fusion. In other words, VMware Fusion, when we create virtual machines, is going to plug those virtual machines into a network, and that network is has a particular network address that we need to know. So what I'm going to do is I'm going to go to Fusion, which I already have running. So for instance, I have this Windows 7 VM. I'll wake it up. There's my Windows 7 VM. I actually don't want to go into the VM itself, but rather I want to go into what's known as the virtual machine library. That's this window here. And the reason why I'm here is I'm going to go select my virtual machine, any virtual machine that I've deployed, and when I look at its settings, I'm going to go check under network adapter to see for my one and only network adapter which network it's plugged into. As you can see in the case of this Windows 7 VM, that virtual machine is plugged into the network called share with my Mac. Now, what does that do for us? Well, what we're doing there is we're determining over here in the terminal window what we need to look for when we run the next command, which is ifconfig-a, and that's going to scroll off the screen. If I want to make certain it doesn't scroll off the screen, I can say pipe space more. And when I run the ifconfig command, which by the way is very much like the Windows IP config command, it gives me information about all my network interfaces. So up on top we see the loopback driver, LO0, and some others, but down towards the bottom we have 3 networks that VMware Fusion has set up. VMnet 1, VMnet 3, and the one that we're interested in if we're doing share with my Mac is the network labeled VMnet 8. As you can see for VMnet 8, it's using a net mask of FFFFFF00, perhaps better known as 255.255.255.0, also known as Class C. And therefore, this internet IP address that we see here, 172.16.245.0, if we mask off that last octet, reveals that the network address for any virtual machine that's plugging into the share with my Mac network is 172.16.245.0, which is a crucial piece of information that we need to know, because any of the machines that we're going to be deploying later on, we're going to be plugging into that network, and we need to make certain that we're using IP addresses in the range 172.16.245.something. Now, if you watch through the rest of the video, including the bonus section at the end, you'll see exactly how I determine a safe set of IP addresses within that range. I can tell you, and you can find out why, but I can tell you that on this network there's a DHCP server, and it's reserving the IP addresses that end in .128 through .254. So we need to make certain we don't pick something in that range. That's why for my ESXi01 and 02 and my other machines, I'm setting them down in the .100 range. Okay, so we've done step 1 to create the RNDC key. Step 2, we found out the network address is 172.16.245.0. The third step is to edit the /etc/named.conf file, which you'll recall is the main configuration file for DNS. Now the challenge here is you're going to be tempted to go to Finder. So here's Finder, and try as you might, you're not going to be able to see the /etc directory here, because in Mac OS X, certain directories such as the /etc directory are hidden by default. Now I did a little poking around behind the scenes. Let me pull up a web browser here. I did a little poking around and found this particular website, and in this website it shows you how you can unhide folders such as the /etc folder. And as you can see here, it's actually just going to clear here in a moment, but the command that they're typing here is a command that reportedly will unhide those folders. Now, as you'll see here in a few moments, I've opted not to go with that approach because I already have a terminal window open, and in the terminal window I can go to any folder that I want. But you could conceivably follow the directions in this website if you wanted to expose those hidden directories, which in turn, in theory, would make it easier to use the plain old text edit utility to edit the following files. But again, we're not going to do it that way. We're going to continue using our terminal window where we're still logged in as that root user. It's crucial that we be logged in as root to do what we're about to do. What we're about to do is to edit the /etc/named.conf file. One quick little point. Let me do an ls dash, let's see, ls is the command in Unix for listing files and directories. If I do an ls-l to get a long directory listing, and -d, which says don't go into the following directory, just list information about it, you'll see that the /etc directory is actually a symbolic link to a directory called /private/etc. Now, to keep things simple, I'm just going to refer to the /etc directory as /etc, even though it's really a symbolic link. So we're going to go into the /etc directory, and in here there are a number of files, including the named.conf file. there's the named.conf file. That's the file that we need to change. And if you look closely at this line here, you'll see that that file is owned by root, which is one of the reasons why we had to su due to the root account. Now, my favorite text editor in the world is the vi text editor. So I could say vi/etc/named.conf and launch the world's greatest text editor, but I suspect some of you out there don't like using vi or don't know how to, so I'm going to use an alternate editor. It's just a text editor called Nano, which is supposedly easier to use. That's a bit dubious, but let's go ahead and use it. So I'm typing nano space /etc/named.conf. I'm already in the etc directory, so if I wanted to, I could just type nano space named.conf. But either way, either using this absolute path name or that relative path name, if we hit enter, we're now in this text editor. Now, all this stuff down on the bottom 3 lines and the very first top line are not actually in this /etc/named.conf file. Those are just the Nano editor putting information on the screen. Now, in the Nano editor, notice that I'm not going to use my mouse. In fact, I'm going to take the mouse cursor out of here entirely to resist the temptation to use the mouse. Nano is not mouse aware. So instead, I'm using arrow keys to go scrolling down. In this controls section, you can see that it says, hey, I've got an RNDC key file. That's the file that we just created before. And below there in the options section, we have our line by default that says that the directory where all the following files are located is the /var/named folder. And then a little bit further down, what I'm going to do is I've actually got it in my clipboard, I'm going to paste in the lines that I mentioned before. So this listen on line and the 3 lines following it tell DNS that we want DNS to listen on those particular IP addresses. Now if we scroll down further, this zone section here is for the root name servers. We talked about that before. This is the zone for the forward lookups when somebody looks up localhost, followed by the reverse domain for when somebody is looking up IP addresses in 127.0.0. And what we're going to do, I'm actually going to cheat here. I'm going to use the mouse to highlight those lines. I'll go up to Edit and choose to copy those. Now, at this point, I have to use my mouse to scroll down where I want to paste in those lines. I'll choose Edit, Paste, and now as you can see, let me scroll back up a bit. Now as you can see, I have duplicated the lines from before. So here's the original root name servers zone, the original localhost forward lookup zone, the reverse localhost lookup zone, and then this section here and here are the things that I just pasted in. And as we saw in the slides earlier, what I'm going to do, delete, 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 I'm going to change this to the vvork.info domain. Now, as I explained before, you obviously need to change the domain name from vvork.info to either your actual domain name or something temporary like example.com. And for the vvork.info domain, I'm going to create a file called vvork.info is going to be the name of the file that contains information that allows us to look up, given a name like www.vvork.info, this file, which is in the /var/named directory, this file gives us the information that we need to map from that name to the IP address of that server. Now down below, in this section, we're going to do the same thing for reverse lookups. Remember, in this part here, we have to reverse the network address, and we drop off the first or last, depending upon how you're looking at it, octet. So the network address is 172.16.245, and since this is a Class C, I'm going to drop off that last octet and reverse it, so I end up with 245.16.172.inaddr.argpath. And for that reverse lookup, I'm going to end up creating a file called named.172.16.245. So I've made all the changes that I need to this file now, and what I'm going to do next is choose the Control-O key sequence that will write out these changes. So I'm typing Control-O. It asks me to confirm, so I hit Enter. And then I'll type Control-X to exit out of this file. Now let's just double check that I did everything correctly here. I'm going to type more space /etc/named.conf. And I'm making certain that I haven't accidentally changed anything in the default parts. And then in the option section, we have our listen on section. We still have our root name servers zone, our forward lookup for localhost zone, our reverse lookup for localhost zone, and then the first vvork.info forward lookup zone that we just created, along with a reverse lookup zone for the 172.16.245 network. So awesome, that looks good. I'll just hit enter or Q to quit to get out of there. And now at this point what we need to do is change directories to /var/named. You'll recall in the /etc/named.conf file that this folder was named as the folder that contains all the lookup files. If we look in here, we're going to see several files, including the ones that you get by default, such as localhost.zone and named.ca and where's the other one? named.local. Those are files that exist by default. Now, what I need to do is to create two more files, and I've actually cheated here. I've already created the two files. I've created one called named.vvork.info. We already know that's the forward lookup file. And I've already created the named.172.16.245 reverse lookup file. If I hadn't created those already, what I would do here is I would start with an existing file, an existing forward lookup file, such as named.local, and I would simply say copy named.local space and then the name of the new file that I'm creating, named.vvork.info. Now I'm not actually going to run that command here because I've already created the named.vvork.info file. I'm just going to backspace to get rid of that. And I would do the same thing for the reverse lookup file. I would copy an existing reverse lookup file, named where's the reverse lookup file? Named it's one of these. Tell you what, I'll just show you. It's one of these files. We can cheat here. Let's see. If we more/etc/named.conf and go look at the reverse lookup file. Okay, so one of them is that one. The other is named.local. Anyways, okay, so you just copy existing files, or you can create the two new files by default. Again, the files that we're going to create, we'll create again using nano. And one of the files is called named.vvork.info, which, as you can see, I've already created. Again, either copying an existing file to get the basic template, or just typing this all from scratch. We need to change the serial number. I explained earlier how that works, so notice I've increased the serial number. And we need to add, for our 4 machines in our lab environment, we need to add the 4 A records that allow us to map from the name of a machine to its IP address. I've already made this change. If you're making these changes, though, you type Control-O to write out the changes and Control-X to exit out. I'm just going to type Control-X. And then we do the same thing for the named.172.16.245 file, which ultimately needs to look like this. Again, in the top part, I'm changing the serial number, and in the bottom part, I'm creating 4 pointer records, which allow us to map from an IP address to a machine name. Again, you'll need to type Control-O to write out the change, and Control-X to save. I'm just going to type Control-X. So at this point, we've gone through steps 1 through 5. Step 1 was to create an RNDC key. Step 2 was to look up the network address. Step 3 was to edit the /etc/named.conf file. Step 4 was to set up our forward lookup file. And step 5 was to set up our reverse lookup file. Now all that's left is step 6, where we're going to actually start named. Now the easiest way to start named is to simply type named. Again, you need to do this as root. But if you just type named, that'll start named. If you want to be more explicit, you can say the -C option, which allows you to specify that the configuration file that named should use is our main DNS configuration file, /etc/named.conf. Now, we don't need to type that because named.conf, etc/named.conf is the default file. We could leave out that -C business entirely. We can also leave out the -D debugging option, which allows us to set up increasing levels of debugging. So for instance, we could say -D space 1 to get a little bit of debugging, 2 to get more, 3 to get even more, and so forth. Now to learn more about named, if you type, I'm not going to run named just yet, because I want to show you how you can learn more about named. If you type the man command, man is short for manual, man space named, you get a manual page that gives extensive details about how the named command works. For instance, it explains here and down below the -C option that I just showed you and the -D option. And if we go scrolling down to the -D option, it tells you that that's the debugging option, or just above there, the -C option is the config option. So there's lots of information about the named command in this manual page. Now I'm going to type Q to quit out of the manual page, and let's actually start named. If I type named, named starts running, and if I want to verify that it's running, if I use the PS command to list processes, I'm going to say E because I want to see every process. F says I want lots of information about those processes. Well, I don't actually want to see all the processes. I only want to see processes that mention named. So this crazy looking grep command that I'm running says take that list of all the processes and filter them. Don't show me every single line and every single process. Just show me the processes that mention the word named. So in the output that we see here, we see two processes. One of them is the grep command that I was running. That matches, but that's not actually what we're looking for. What we're looking for is the line above, where we can see that named is running, and if necessary, we can also see important information such as the process ID of named. So named in this case is process ID 29737. So if ever I need to manually kill off that process, I could say kill -15, read the man command for the read the man page for the kill command to find out what this -15 or the -9 options mean. They're signal numbers. Read the man page for kill to find out more. But if we say kill space -15 29737, that will gently kill off the named server. Anyways, our named server is now running, and if we configure our MacBook Pro to use DNS, we're going to want to tell it that it needs to use the DNS server at 192.16.245.5. Again, that's the IP address that we told the DNS server to listen on. Or if we're going to go configure that Windows 7 VM, again, the same DNS server IP address is what we'd specify there. So this was a step-through demonstration of all the steps involved in setting up the DNS server. That should get your DNS server up and running. There's one more bonus section in this video, which if you want to skip it, you can, but I think there's some valuable information in there that you'll want to take a look at. In particular, it's in this bonus section that you're just about to see that I explain how I knew that in the range of IP addresses, 172.16.245, that I should not use .128 through .254. Instead, I was using .101, 102. The bonus video section explains how I knew that. So this concludes our demonstration. As a bonus, so here's that bonus I was talking about earlier in the video. I learned some things about Fusion as I was doing this project. In particular, I learned about how its DHCP server works. You can actually make changes to the DHCP server, and you can do things like tell the DHCP server that for certain machines it should assign static IP addresses. You can modify the DHCP server, but notice the second bullet. I have no clue. I haven't asked our support folks whether or not these modifications are officially supported or not. So don't recommend doing this in a production environment. Then again, you probably should be careful about running a DHCP server in a production environment anyways. All right, so continuing onwards here. Third bullet, important point. This bonus stuff that I'm showing you here is actually not relevant to the rest of the videos. In the rest of the videos, I'm not using the DHCP server that's baked into Fusion at all. I'm just using statically assigned IP addresses, such as the ones that we saw when we configured named and DNS. So if you want to, you can skip the rest of this video, but I think there's a couple of interesting things in here if you hang on. So last bullet here, the DHCP.con file. That's the configuration file for a DHCP server. Fusion actually potentially has multiple DHCP servers, one corresponding to each of the networks in Fusion. And you can create your own networks in Fusion. So finding the right DHCP.con file for the right DHCP server for the right network was something that I had to figure out. So let me tell you how I got there. I noticed in the configuration of my virtual machines that my VMs were getting plugged into what's known as the share with my Mac network. You may be plugging your virtual machines into a different network, in which case the following information needs to change slightly. But in my machine where I'm running Fusion, my share with my Mac network has a DHCP server, and the configuration for that DHCP server and other things about that particular network are down in /library/preferences/VMware Fusion /VMnet8. So down in that folder, there's a file called dhcp.conf, and in that file there are a few entries by default. There's a subnet section and another section which we'll talk about in a moment. But notice that the subnet section is effectively declaring that we're going to have a DHCP server for the network 172.16.245. By the way, it's a class C. That's why it says 255.255.255.0. And this DHCP server is going to dynamically assign IP addresses for that network. But the IP addresses this DHCP server is going to hand out are limited to the range 172.16.245.128 through 245. Now there's some other entries in here that give some optional information. For instance, if a machine plugged into this network requests that DHCP give it an IP address, it's also going to find out through the DHCP server that the broadcast address that client should use is 172.16.245.255. And it also finds out about the domain name servers and the domain name that should be slapped on short name lookups, plus lease information, plus NetBIOS name server information, plus routers. There's all sorts of stuff that you can stuff into the dhcp.con file. Now, when I was doing this project initially and I decided to have the DHCP server assign statically assigned IP addresses, I didn't need to make any changes to this subnet section. But I did need to find out the range of IP addresses, which we saw here. That's true both with the first approach that I was taking and the ultimate approach I took, which is I'm not using the DHCP server to assign the IP addresses for my ESXi01, ESXi02, VCVA, or VCO. I'm not allowing the DHCP server to assign IP addresses to those machines dynamically, nor am I configuring the DHCP server to do so statically. Instead, I just effectively turned off the DHCP server and I'm just manually assigning static IP addresses. Anyways, continuing onwards here, in the default dhcp.conf file, there's a host section, an entry that says host VMnet8, which effectively is saying that this DNS server, this DHCP server that we're setting up is going to show up on the network at the MAC address that you see listed here and at the IP address that you see listed here. Now again, I didn't need to make any changes to this portion of the DHCP.con file, but what I did do was duplicate the host VM8net section to create a new section, host ESXi01, for information about this address, the IP address that I wanted statically assigned to that machine called ESXi01. So ESXi01, I know from going into the settings for the virtual machine in Fusion, I went in there and looked at the network settings for this virtual machine. I found its MAC address, which is the one that I've listed here. So I took the MAC address that I found in the Fusion settings for this virtual machine and plugged in the MAC address here. And then on the fixed address line, what I'm specifying is, okay, DHCP server, if you see somebody at that MAC address requesting their IP address, then give them this statically assigned IP address, 172.16.245.101, which, if you recall from the previous slide, is outside of the range of IP addresses that the DHCP server is assigning. So 101 for the first host. Continuing onwards, I add another section for information about my second host, and so on and so forth. Again, you don't have to do any of this except perhaps figure out what the range of IP addresses is that your DHCP server is assigning, so that when you do, as I'm going to do in the rest of these videos, you can make certain that your statically assigned IP addresses that you're giving out don't collide with the IP addresses this DHCP server is handing out. Okay, so that's it for this particular video. In the next video, what we're going to be looking at is how to install the first of our 2 ESXi hosts. So see you in the next video.